What's going on, everybody? Johnny Bannon here at Trepa Technologies, and today we're going to be going over domain 2.3, which is all about wireless. We're going to have two sections here. First section, we're going to go over pretty much fundamentals of wireless and Wi-Fi, and then we'll finish up going over the difference between the protection in Wi-Fi, so WPA2, WPA3, the difference between enterprise mode and PSK mode when we're talking about our Wi-Fi or wireless networks. So let's go ahead and take a look at our objectives here. Move my face over here. Okay, so we're going to be going over everything on the left here in this first video, and that's going to be channels, frequency options, SSIDs, and the different network types in our wireless networks. So before I kind of dive right into wireless channels, I just want to give a brief overview of what Wi-Fi is, kind of the history of it, or just the bare bones fundamentals. So Wi-Fi, or wireless signals, or wireless network, at its base is just a device, like an access point, radiating an electromagnetic signal on a certain frequency range, and then obviously that radiates out an antenna. That antenna is going to be transmitting and also going to be able to receive on that frequency range. And then another device, also with an antenna, is going to be able to receive that signal and also transmit. Those two devices, access point and Wi-Fi enabled device, have what a wireless NIC connected to an antenna. That antenna is radiating signals to each other that they can both listen to. Now their frequency range is going to depend on how much data they can send across. So we think about a frequency, a sine wave, right? A cycle. Depending on what range you're in is how much data can come across. So there's a lot of different things that can change how much data can be coming across on that frequency range. And when we get that analog signal, we have to turn it into digital. So on that motherboard of a computer, antenna, receiving a signal, we modulate that analog signal, that electromagnetic signal, that Wi-Fi signal into digital, into binary, and then encapsulate it up. Now when we transmit, we de-encapsulate down, right? Change that digital signal into analog, put it out on the frequency range that we're tuned to, which we're going to learn is 2.4, 5 gigahertz, or 6 gigahertz when it comes to Wi-Fi, and send it out to our access point. The access point is sending but also receiving that frequency range. In that frequency range is going to do the same process and then send it out to the distributed network, out to the internet. So that's just as bare bones as I can talk about frequency, okay? My job when I was in the Army was satellite communications, which again works in RF, works in radiated frequencies. So when we talk about wireless, something I'm very familiar with, but I don't want to dive too deep. Just kind of want to put that out there, kind of what a Wi-Fi signal is, okay? It's just a electromagnetic signal that we measure in what's called cycles or hertz, right? And depending on that range is better or less data. But then because we're working in that RF, we can have a 2.4 gigahertz range and a 5 gigahertz range. 5 gigahertz is that wider band with stronger frequencies, which means it's tighter signal, so more data per the cycle, but it can't go, you need more power to radiate it farther, okay? And it doesn't go through objects as well as 2.4 gigahertz would. So now that we got that out of the way, let's go over wireless channels. So wireless networks operate using channels. So in the 2.4 gigahertz range, we have 20 megahertz channels. That's the most narrowest option. So we have 20 megahertz, that's 20 megahertz, we talk about our cycles, channels in the 2.4 gigahertz range. So this has minimal interference but has a lower data rate because the channel is a little bit smaller. In the 5 gigahertz range, we have 40 megahertz. Now we can also do like channel bonding maybe in 2.4 gigahertz. That doubles the data rate by using twice the frequency range, but can cause more interference and cannot travel as far. So kind of the saying goes, if you're in 2.4 gigahertz, you put it in the middle of a football field, that 2.4 gigahertz is going to radiate the whole field. 5 gigahertz won't, because you're going to need more power for that increased signal, right? That increased range, that frequency range, channel. And then we have 80 and 160 megahertz. These are wider channels mainly used in the 5 and 6 gigahertz bands to achieve much faster data rates, but they are much more susceptible to interference. And that's because you need more power, and they're going to attenuate a lot more easier than a 20 megahertz channel would, okay? Now, of course, we really were to dive into wireless. We could talk about like QAM, phase shift keying, MIMO, other things that allow us to have those increased channels with better range and less interference. But this is just the basics. So channel width. Channel width refers to the size of the frequency band used by our wireless signal. The wider the channel, the more data can be transmitted at one time. However, wider channels are more prone to interference from other devices and networks. Like a microwave can interrupt wireless signals. Okay, so now on those channels, we want to make sure we're non-overlapping. So non-overlapping channels in wireless networks, especially the 2.4 gigahertz band, some channels overlap with each other. So we need to figure out what channels don't overlap. When we say channels, right? So we talked about channel width, 20 megahertz. So what am I talking about here? Well, when we look at the 2.4 gigahertz range, so this is the 5 gigahertz range I have down here. But we look at the 2.4 gigahertz range, that is 2.4 to actually 2.5 gigahertz. That's the entire range we have. And then within that range, 2.4 to 2.5 gigahertz, we have channels in there that are 22 megahertz range, or 20 megahertz, okay? They say 20, 22, whatever, it's fine. You know, both are fine. So you can see down here where each range starts, and we have channel numbers designated to them. So channel 1 starts at 2.412, and it goes all the way to about 2.43, right? 2.4.2529. Then channel 6 starts at 2.437, and channel 11 starts at 2.462. So they're not overlapping. And the reason we can't have those overlapping channels is because we get interference, right? So in 2.4 gigahertz, the only non-overlapping channels are 1, 6, and 11. In the 5 gigahertz band, there are more non-overlapping channels due to the wider range of available frequencies, allowing better performance in the crowded areas. So what we're saying here is that in the 5 gigahertz, we start from 5 to about almost 6 gigahertz, or 5,000 megahertz to almost 6,000 megahertz, right? Okay, so regulatory impact. So let's go over 802.11h. And just to let you know, wireless, the IEEE standard is 802.11. So we talk 802.11 frames. We have 3 different types of frames in 802.11. It's not talked about in these objectives, so don't go over it, but just want to let you know that. But let's go over regulatory impacts. So 802.11h. Regulatory impacts refer to rules and regulations that wireless devices must follow depending on the country or region. To comply with these regulations, certain features were added to the Wi-Fi standards. One of the key regulatory standards is the 802.11h standard, which is an amendment to the original 802.11 standard. That's the IEEE 802.11 standard that defines Wi-Fi, or really wireless signals, okay? So DFS. This prevents interference with radar systems by automatically shifting the Wi-Fi signal to a different channel if radar activity is detected. And then TPC, the transmit power control. This adjusts the transmit power of a wireless device to minimize interference and reduce signal range when necessary. So what we're saying here is that some of our critical infrastructure may run on a similar frequency range, and we don't want our Wi-Fi interfering with something like radar, okay? So that's 802.11. Okay, so here's our frequency options, kind of just more clear. So here's that 5 gigahertz range at 40 megahertz wide. We can see all the different channels we have, 38, 46, 54, 62. Our DFS channels, right, that don't interfere with radar, okay? Here's the 2.4 gigahertz range with our 22 megahertz channel. Then 6 gigahertz. So that's kind of like for the new Wi-Fi 7 standard, the brand new standard, or Wi-Fi 6E. So 6 gigahertz frequency band is the newest addition introduced with Wi-Fi 6E. It offers more bandwidth, less interference, and significantly more non-overlapping channels compared to 2.4 and 5 gigahertz. If you're ever wondering, why don't we just do that from the start? It's because of power, guys. It's because you need more power to generate those higher frequency channels, higher frequency ranges. And it's hard for our access points that are getting powered by switches of power over Ethernet to grant that power, right? So it just comes down to architecture, design, and what it actually takes to get those increased ranges. And then of course, 6 gigahertz, 5 gigahertz range, they can't go through walls as good. They can't go through objects as well as 2.4 gigahertz can. Okay, band steering. So band steering is a feature used by modern wireless routers and access points to automatically direct dual band devices to connect to the 5 gigahertz range, or now the 6 gigahertz, instead of the 2.4 gigahertz band if it's more congested. So it just lets us kind of choose the band, right? Well, let me connect to 5 gigahertz. I'm getting a strong signal there and it's less congested. Let me move to that band, okay? Because it doesn't matter what when you create an SSID on that access point, we're about to go over this, and you're broadcasting that signal, that SSID is going to be for the 2.4, the 5 gigahertz range, but it's the same access point, right? So you're connecting to the same access point whether or not you're on 2.4 or 5 gigahertz. That just, that 2.4, 5 gigahertz is just the Wi-Fi signal, but the access point's generating it. So you'll get to the same spot whether you connect to the 2.4 or the 5 gigahertz range. Okay, and before we move on, I want to show you guys an application here called Insider. You can download this. I don't believe I pay for it, but it can just on any laptop, anything that has a wireless NIC, you can use Insider and look at all the other overlapping channels, right? So this is the Wi-Fi I'm on, Trepa Technologies. You can see the signal, so you can see really the SNR, the strength, right? See Trepa Technologies here. You can see I'm using Ubiquiti, WPA2 Personal is the encryption I'm using. And you can see I'm operating in the 2.4 and 5 gigahertz range. And there's my channel there. And here's my channel here. So it looks like I'm going from 4 to 8, right? Okay. Starting at 4. Awesome. So let's go ahead. You can see the utilization. Other things here we're not going to really get into like too deep, but Insider can let you see SSIDs, even hidden SSIDs. That's why they say hiding SSID doesn't really protect you if someone's wants to attack your Wi-Fi, right? Exit out of that. Okay, SSID. So that stands for the Service Set Identifier. The Service Set Identifier is a name of a wireless network that is broadcasted by the access point so that clients can identify and connect to it. So an SSID is broadcasted by the access point, but an SSID actually equals a wireless network. And what I mean by this is, in a big enterprise, if we have multiple VLANs, and now we set up Wi-Fi, and we want SSIDs to correlate to those VLANs, and those VLANs correlate to a broadcast domain, a subnet, we can have a single access point broadcasting multiple SSIDs that correlate to a wireless local area network, meaning it correlates to that VLAN, it correlates to that network, okay? So yes, an SSID is broadcasted by the access point, but an SSID actually represents the wireless network you're connecting to. So I could set up on my Ubiquiti network here 10 SSIDs being broadcasted by my access point in the other room, and each SSID will represent a wireless network I can connect to, okay? A basic service set identifier, the BSSID, is the MAC address of that specific access point that you are connected to within a wireless network. We have the extended service set identifier, the ESSID. This is the SSID of a network that consists of multiple access points and allows you to seamlessly roam. So that is something we configure in, like, again, a big enterprise where multiple access points are working together to do roaming, okay? So we have that extended service set identifier. So your user can get up and walk between offices and still stay connected to the SSID that they need to be connected to. The different network types. So we have mesh networks. So typically these are used in autonomous access points. We'll go over that, where we kind of mesh together, where we set up one wireless access point, and as long as it has a signal to another access point, maybe a third access point, we can say, hey, we're generating the same SSID, all of us, and it kind of allows that roaming as well. But this is for autonomous access points, okay? We'll get into that, but a mesh network consists of multiple nodes that work together to provide seamless coverage across a large area. Then we have ad hoc. So an ad hoc network is a temporary network where devices communicate directly to each other. So this could be two laptops running Windows that set up a wireless, they put up a wireless signal, and that's how they connect to each other. Almost like they're connecting with Cat5 or Ethernet, but instead it's wireless. So it's peer-to-peer communication. That's an ad hoc network. And then point-to-point, not necessarily ad hoc, right? Point-to-point is something that's like dedicated. That's like, hey, I need to talk a mile down the flight line. I can't run Cat5. I don't have single mode fiber to run underneath. I need to just do it quickly. So we set up like ubiquity air fiber. That's point to point. That's like line of sight, directly connecting to each other. And it's going to be a strong signal, okay? And we're going to get like 800, maybe a gigabits speed on that point-to-point wireless network. It's really directional, right? Directional point-to-point specialized equipment for that line of sight over long distances, sending the wireless signal over miles of range, right? Up there on the screen, I have ubiquity air fiber. I've used that before when I was in the military to do point-to-point between different areas we were operating in. And then infrastructure mode. So infrastructure mode is the most common network type for Wi-Fi networks. In this mode, wireless clients connect to an access point, which provides connectivity to the larger network. So what we're saying here is that, hey, our access point is actually just getting us back to our distributed backbone network, our actual wired network, okay? Back to our ISP. So this is the mode used in most homes, offices, and public Wi-Fi networks. All right, let's go ahead and do our quiz. I'm already here, so let's go ahead and go to our CompTIA Network Plus. We're going to come here to quizzes. We're going to scroll down. We're going to start this quiz, domain 2.3.1. Let me move my face down here into view. All right, so question 1. I'm going to zoom in just a little bit too. In which scenario would you most likely use a point-to-point wireless network? I'm going to go with D, connecting two buildings on a corporate campus across a long distance. It's true, when our wired connections can't do it, or it's just not feasible. Question 2, which of the following best describes the function of band steering in a wireless network? I'm going to go with C, automatically connecting dual band devices to the 5 gigahertz or 6 gigahertz band. Just switching between bands, right? Automatically. Question 3. Which wireless technology ensures compliance with regulations regarding radar systems, interference in the 5 gigahertz band? That's going to be the dynamic frequency selection. Question 4. What is the key feature of a mesh network compared to a traditional infrastructure wireless networks? Let's go with C. In a mesh network, multiple nodes work together to provide coverage and automatically reroute data if one node fails. Question 5. What is the primary benefit of using the 5 gigahertz frequency band over the 2.4 gigahertz band in a wireless network? It's not longer range, doesn't penetrate better. I'm going to go with B, more non-overlapping channels and less interference. And all right, let's go. We got 100%. So I want to thank you all for viewing. Don't forget to like and subscribe, share with your friends, hit that bell, and stay tuned as we finish up our Domain 2 section of the Network Plus exam.